Namaste. Welcome to the last week of machine learning practice course. In this week, we'll study how to implement artificial neural network or multilayer perceptron neural network models for classification and regression tasks with sklearn. Let's look at multilayer perceptron. So there are different names for artificial neural network. It goes by the name multilayer perceptron or feed-forward neural network. So we will be using multilayer perceptron as the name throughout this slide deck. So multilayer perceptron is a supervised learning algorithm. It learns a nonlinear function approximator for either classification or regression tasks depending on the dataset. In sklearn, we implement MLP using MLP classifier and MLP regressor for classification and regression respectively. MLP classifier supports multi-class classification by applying softmax as the activation in the output layer. It also supports multi-label classification in which a sample can belong to more than one class. MLP regressor also supports multi-output regression in which a sample can have more than one target values. The training data is represented in form of a feature matrix X with shape, number of samples, number of features. And the output is an array Y or a vector Y that holds the target variable, and this vector has number of components equal to number of samples. Let's see how to implement the MLP classifier. We first instantiate MLP classifier estimator object. So MLP classifier is implemented in sklearn.neural network module. We first instantiate MLP classifier with all default arguments. Then we call the fit method on MLP classifier object with training feature matrix and label vector as arguments. In the third step, after fitting the model can make predictions for new samples using one of the two methods. We can use predict to obtain the class labels and predict_proba method to obtain the probability distribution over k different classes. So predict, as I said, gives label for new examples. So the new examples are passed as input. This is the feature matrix corresponding to the test examples, and we obtain the labels for each example in the feature matrix. Whereas predict_proba gives a probability distribution over the class labels. So here, for a binary classification, we obtain two values through predict_proba. This is the probability of a sample belonging to class 0, and this is the probability of sample belonging to class 1. And you can see that this particular sample will belong to class 1 if we perform predict or argmax, because this probability value is much higher than the other probability value. So note that MLP classifier supports only cross entropy loss function. Let's see how to set the number of hidden layers. We can set it with parameter hidden_layer_sizes. This parameter sets the number of layers and the number of neurons in each layer. It is a tuple where each element in the tuple represents the number of neurons at the ith position, where I is the index of the tuple. The length of the tuple denotes the number of hidden layers in the network. To create a 3 hidden layer neural network with 15 neurons in the first layer, 10 neurons in the second layer, and 5 neurons in the third layer, we essentially set the parameter hidden_layer_sizes with a tuple with 3 values, which is 15, 10, 5. So the length of the tuple implicitly represents the number of hidden layers, and the first hidden layer has 15 neurons, second one has 10 neurons, and the final one has 5 neurons. Let's see how to perform regularization in MLP classifier. The alpha parameter sets L2 penalty of regularization parameter. So alpha is a parameter which takes float values, and by default it takes value 0.0001. Let's see how to set the activation functions for the hidden layers. So there are 4 activations. One is identity that returns the parameter itself. Then there is a logistic which computes the logistic sigmoid function on the input value. Then there is a tanh function that calculates hyperbolic tan function on the parameter, and ReLU, that is rectified linear unit, which finds the max between 0 and the input. ReLU is a default activation function for the hidden layers. Let's see how to perform weight optimization in MLP classifier. MLP classifiers optimizes the log loss function using LBFGS or stochastic gradient descent. It can use one of the following solvers. It could be LBFGS, HGD, or ADAM. ADAM is used a solver by default. If solver is LBFGS, the classifier will not use mini batch. The size of mini batch can be set to other stochastic optimizers by using a parameter batch underscore size, and it should take an integer value. The default batch size is auto and it is set to minimum of 200 common number of samples. So it is minimum of these two numbers that is set as a batch size. Let's see how to view the weight matrix coefficients of the trained MLP classifier. We can obtain it using coeps underscore, just like other estimators. In this case, it is list of shapes and layers minus 1, comma. So basically we have vectors equal to the number of layers. And the ith element in the list represent the weight matrix corresponding to layer I. So if you want to find out weights between input and the first hidden layer, we can obtain it by finding the coeps of 0. So coeps of 0 will give weights between input and the first hidden layer, whereas coeps of 1 will give us weights between first hidden layer and the second hidden layer. So these are sample weights between first and the input and the first hidden layer and first and the second hidden layer. Let's see how to view bias vector of trained MLP classifier. It can be obtained using intercepts underscore member variable. You can see the bias value for the first hidden layers using the 0th index of intercepts underscore member variable, whereas bias value for the second hidden layer can be obtained by using index 1. So these are sample bias values for the first hidden layer and the second hidden layer. Let's look at some other parameters in MLP classifier. There are parameters like learning rate, which can be either constant, inverse scaling, or adaptive. The default is the constant learning rate. The learning rate is initialized to float value, which is a default value of 0.001. There are other parameters like power underscore t with default value of 0.5 and max iter with default value of 500. Learning rate and power t are used only for solver HGD. Learning rate init is used for solver HGD or ADAM, and shuffle is used to shuffle samples in each iteration when solver is HGD or ADAM, and momentum is used for gradient descent update when solver is equal to HGD. Let's look at MLP regressor, which is used to train the regression models. MLP regressor trains the regression model with backpropagation, and in this case there is no activation function in the output layer. It uses square error as a loss function. The parameters of MLP regressor are same that of MLP classifier. Let's see how to implement MLP regressor. We instantiate MLP regressor estimator. We call the fit method with training feature matrix and label vectors as arguments. After training the model, we can use it for making predictions for the new samples. So we can use predict method with test feature matrix as an argument. It returns predicted values for new samples. We can also obtain the score by providing the test feature matrix and test output labels. It returns R square score for the regression. In this video, we looked at couple of MLP implementations, which is MLP classifier and MLP regressor, that is used for implementing classification and regression problems in sklearn using artificial neural network or multilayer perceptron.